Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student, welcome back to study second term. Dear student, first secondary. Today we will talk about the thermochemistry, first lesson in second term. What about thermochemistry? What's the meaning of thermochemistry? Thermochemistry science deals with or studies the heat change in chemical reaction due to physical change or chemical change. Okay? And what the meaning of thermodynamic? Also science, but deals with the study of energy and how it transfers. We know the energy transfers from form to another. As electric changes to light, according to the law of conservation of energy. Energy in any physical or chemical change can be neither created nor destroyed, but it change or transfer from one form to another. Okay? When chemical reaction occurs, the reactants called system and outside the reaction called surrounding. So what's the meaning of system? Part of substance under study, or part of the universe in which physical or chemical change occurs. If we have two substances A and B react with each other, A and B called the system, and outside of this system called surrounding. Okay, as in this figure, system outside called surround, and the beaker or flask called system boundary. There are three types of system: isolated system, open system, closed system. What's the difference between them? Isolated system don't exchange neither energy or matter with the surround. No change in energy, no change in matter. Isolated system. While open system, there are two exchange, matter and energy. Okay? As we see in the sea. Sea can be cold, can be hot, and filled with water by rain, or decreases its water by evaporation. Okay? Why closed system? It is a system in which only one exchange, which is energy, no matter change, no matter transfer to it. No matter transfer from it. Now, first law of thermodynamic states that the total energy of isolated system is constant if the system is changing from one state to another. How? If we have chemical reaction, release heat. The amount of heat released equals the amount of heat absorbed, but negative sign. Okay? Now, what's the difference between heat and temperature? If we have two beakers, each of them contain water. One of them, its temperature 80 degrees Celsius and the other 20 degrees Celsius, and we make mixture between them. Okay? What do you think? Transfer of heat from 80 degree to 20 or 20 to 80? Yes, from 80 degrees Celsius to 20 degrees Celsius. So, the heat transfer from higher temperature to lower temperature. Heat is energy, temperature not. Temperature not energy, okay? Temperature indicator of hotness or coldness, and reference to us how the heat energy transfer from or to the object, okay? That's the difference between heat and temperature. Now, the measuring unit of quantity of heat. There are two units, calorie and joule. The calorie is the quantity of heat needed to raise temperature of 1 gram of water by 1 degree Celsius. If we have beaker contain 1 gram of water and I wanted to raise its temperature from, say, 15 degrees Celsius to 16 degrees Celsius, I need 1 calorie. While joule This is a quantity of heat needed to raise temperature of 1 gram of water, but by 1 over 4.18 degrees Celsius. So the calorie greater than joule. 1 calorie equal 4.18 joule. Okay? Now, what's the meaning of a specific heat? Specific heat, quantity of heat needed to raise the temperature of 1 gram of substance, not water only. 1 gram of substance, 1 degree Celsius. Okay? So there are a specific heat for iron, for copper, for aluminum, for water. Okay? And its measuring unit joule per gram degree Celsius. Specific heat is constant, doesn't depend on mass or temperature, but depend on physical state of the substance. So specific heat of water different in liquid state and vapor state or gas state. Specific heat of water greater than specific heat of water vapor. Okay, so the water used in extinguishing fires. Now we calculate the quantity of heat. Quantity of heat absorbed or released can be calculated by the following relation, which is Q is quantity of heat at constant pressure, measuring unit joule. M is the mass of substance, measuring unit gram. C, specific heat, its measuring unit joule per gram degree Celsius. And delta T is the change in temperature, T final minus T initial. Okay? Now, example, you use a calorimeter. What is a calorimeter? This device used in measuring a quantity of heat released or absorbed. Now, using the calorimeter, 0.28 gram of propanol was poured. The temperature of water increased by 21.5 degrees Celsius. 21.5 degrees Celsius means that change in temperature, not T final, not T initial, but it is delta T. Okay? If you know that the mass of water in calorimeter 100 gram, calculate the realized quantity of heat from the burning of this amount of fuel. The answer, we write the law. Q equal M dot C dot delta T. Mass multiply specific heat multiply change in temperature. Okay? Now, the device that used in measuring quantity of heat, calorimeter or pump calorimeter. The structure, both of them same, but pump calorimeter have an ignition wire to make spark for combustion reaction. Okay? So the pump calorimeter used in combustion reaction. Both of them contain isolated container, thermometer, and stirrer. Thermometer used to measure temperature 1 and temperature 2, initial and final. Okay? While pump calorimeter the same, but contain ignition wire to make electric spark for making combustion reaction. Okay? Both of them we use water because it's highest specific heat. Okay? Thank you. Goodbye.